Hey, if you're on the fence about the moon landings, you think maybe they didn't happen, watch this video and I think I can convince you that they were faked. Okay, in this video right here, we're comparing how fast it takes the SLS to clear the launch tower versus how long it takes the Saturn V to clear the launch tower over here. Here we go. Also comparing how fast they accelerate off the ground. Took about little over 6 seconds for the SLS to clear the launch tower. The Apollo's not even halfway up. It took about right at 12 seconds for the Saturn V to clear the launch tower. Okay, now in this infographic, we're going to compare the thrust to weight ratios of the Apollo Saturn V rocket to the SLS Artemis rocket. Okay, the Saturn V had a 7.5 million pounds of thrust divided by 6.2 million pounds was its weight at takeoff, gives you a thrust to weight ratio of 1.21. The SLS right here had a 8.8 million pounds of thrust, maximum thrust at liftoff, divided by 5.75 million pounds at takeoff, gives you a thrust to weight ratio of 1.53. Now, just for comparison's sake, the Starship weighs it at 9.7 million pounds, so take 16.7 million pounds divided by 9.7 gives you a 1.72 thrust to weight ratio. So the Starship should take off the launch pad a lot faster even than the SLS. Okay, now the thrust to weight ratio is very important in rockets. The higher the thrust to weight ratio, the better the rocket accelerates off the launch pad. The lower it is, the slower it will accelerate. And if it's 1.00 or less, it'll just sit there on the launch pad and weigh nothing, because basically if it was 7.5 million pounds of thrust and the rocket weighed 7.5 million pounds, it would just sit there and not go anywhere until it started burning off the excess propellant, and then it would weigh less, and then it would slowly start to rise. So you want your thrust to weight ratio to be as high as possible. Okay, now first let's look at the diagram of the Saturn V rocket. You've got the first stage, you've got a second stage, and then you've got a third stage. And as each one burns off its propellant, it falls to the ocean or to the ground and burns up, and each part is left behind. The only part that comes back to Earth is this little Apollo capsule right here. So you got the first stage, the second stage, the third stage, which actually helped get it into a stable low Earth orbit, but then also propelled it to the moon. This part actually went to the moon along with the lunar module, which is right here. The command module is right here, and the service module. So the command module, the service module, the lunar module, and the S4B third stage rocket all went to the moon. They separated halfway there, and then this part went on to either go into deep space, or maybe it fell back to Earth, or maybe it fell to the moon, but it went by the moon, just like the rest of this stuff. So these four parts all went to the moon. Similarly, you have the SLS. You could say that the solid rocket boosters are the first stage, but the core stage plus the solid rocket boosters got it off the launch pad. Then these fell away, and then this thing continued. You could say that's the second stage. And then you have the third stage, interim cryogenic propulsion system, which is basically the third stage of this rocket, and it got it into a stable low Earth orbit. But then also it fired again to do the translunar injection, which propelled the rest of this to the moon. Okay, now the parts that went to the moon on the SLS are the command module here, the service module, and the interim cryogenic propulsion stage. Now this part separated from the other two, and then this part is the part that went around the moon and went into a distant retrograde orbit, and then came back by the moon, and then came back to Earth. This part actually continued off into space, so I'm considering that as going to the moon also. All right, so going back to this diagram here, for the Saturn V, the command module weighed 13,000 pounds, and the service module weighed 55,000 pounds, fully fueled. And the lunar module which was in here somewhere, weighed about 33,500 pounds, and then the S4B rocket weighed 29,700 pounds empty. And then in the Apollos 15, 16, and 17, they also had a lunar rover, which weighed in at 460 pounds. You add all that up, and this is the amount of weight or mass, 131,660 pounds, that was sent to the moon. and it took them 3 days to get there. That's the official NASA story. Now, the SLS, on the other hand, had the command module, which weighed 21,900 pounds, the service module, 31,100 pounds, and the ICPS, or basically the third stage, which weighed 8,400 pounds empty. And we're going to assume that in both cases, all the propellant we used could get them to the moon, as in all the propellant was used out of these other ones also. So you add all those up, and that comes to a grand total of 61,400 pounds that the SLS sent to the moon, or around the moon, and it took them 5 days to get to the moon. Okay, now it was 1961 that JFK set the goal of getting to the moon before the decade was out. And 6 years later, 1967 is when the Saturn V rocket was operational. 6 years later, we had a rocket that could do all of this, supposedly. Supposedly, they're saying, NASA says that we sent all this weight to the moon in 3 days. In 6 years, they developed a rocket. Okay, and now, approximately 55 years later, we have the newer technology, rocket, new electronics, new materials, better rockets, better everything, supposedly, and we can only send half the weight to the moon, and it takes twice as long to get there. This is not what I'm saying. This is what NASA is saying. You can get all this information, and it all comes directly from NASA. I think that this thing is actually doing this, and I think that this thing probably barely made it into orbit, and there's no way they got that much weight to the moon in half the time that this thing did. Hey, and if you like this video, please do me a favor and hit the like button. And if you want to see more content like this, hit the subscribe button so you can see my newest videos. This is Conspiracy Todd, and I'll talk to you later. Bye.